Hi and welcome to Precalculus. Today's topic is the Moivre's theorem, answers in trigonometric form. So we actually looked at this thing in the previous lecture. The idea is that if you have a complex number given to us in a polar form, r times cosine of theta plus I sine of theta, then if you raise it to power of an integer n, it's simply r to power of n times cosine of n theta plus I sine of n theta. Explanation of this thing was in the previous video. Now we are going to take a look at several examples. The first one, here's angles given in degrees, and we want to take this complex number and cube it. How do we do that? Well, the r of it is 6, and 6 cubed is 216, so this number is going to be 216, and these numbers are going to be simply a triple of whatever angle we had before. Angle was 65 degrees, we multiply it by 3, becomes 195 degrees, and so that is that's all there is to do it. 195 degrees is the item in those two boxes. This is a very similar one. This is the z that's given to us. We want to raise it to power of 4. 2 steps, 5 to power of 4 and 5 to the power of 4. That's going to be 625. So this number is 625. And the angle, well, we take 3 pi 8, quadruple it, so it becomes 3 pi half. So these two angles are 3 pi half. In this case, if you want to simplify it further, 625. Well, it's saying give the answer in trigonometric form, so we just leave it as that. However, if you want it for your own uses, cosine of 3 pi over 2, you know that 0, and this is sine of 3 pi over 2 is minus 1, so the answer becomes 625 times minus I. But you leave it the answer in that form, because that's the form it's asking for. Similar example here, r is 4, 4 has to be raised to power of 5, and that is 2 to the power of 10, which is a famous number, 1024. In computer language they refer to it as a kilo, or as 1k in computer language. Anyway, this number is 1024, and the other one we have 110 degrees times 5 is 550 degrees, so you can write it as 550 degrees. If you wanted to simplify it, you can subtract 160 degrees from that and instead write 190 degrees, so we know where the angle is. Original angle is 110 degrees. If we repeat this thing 5 times, after 5 times, so it comes out to 190 degrees. That is the final angle for our problem. So simple procedure, so long as we apply the Moivre's theorem. Here is the statement of theorem. So it was simple and useful. I didn't see an example in your software where they would use a negative exponent. That's legitimate as well. So if I have say 2 cosine of say 50 degrees plus I sine of 50 degrees, and the whole thing is raised to the power of say minus 3. Still true, 2 to the power of minus 3 is 1/8, and cosine of minus 3 times that is minus 150 plus I sine of minus 150. Of course, we can go ahead and simplify this thing further. I just wanted to say this is true so long as n is an integer, so it could be 0, 1, 2, 3, could be minus 1, minus 2, minus 3, and so on. The only thing that's left out is what if n was a ratio. That will be requiring some additional work. We are going to talk about that in a future lecture. Until then, good luck and God bless.